And once again, read this important announcement. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. Like if you're on the FBI's most wanted list, you know, you don't want your picture out there. Sorry. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Blah, 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 right? Okay. So today we're going to go on to section 6.3, but first I have several requests from people. So we'll start with those problems. This is from section 6.2. As I mentioned, I believe yesterday, a couple things I want to mention. One, Math Center hours, there they are, in case I didn't mention that. And you can always catch that on the video later. Also, you may not have the exact same problem as the one I do, because when you look at WebAssign, there's numbers that are in red. Those may change from student to student. So this is the question that the specific person asked for. We're going to take a look at problem number 23. First of all, your number 23 might have different numbers, but it should be the same general idea. Okay, here we go. So we have, it says, choose the correct method to factor completely the following. If the expression is not factorable, enter, let's see what it says here. I got to move that thing over, enter prime. Okay. So it says 12 n to the 5th power minus 48 n to the 4th power minus 36 n to the 3rd power. Okay, now this is a trinomial and it's descending powers. But it has a greatest common factor of 12 n cubed. You see where I got the 12 n cubed, everybody? 12 goes into 12, it goes into 48, it goes into 36, and then n cubed. So now the question?
I don't really know where you're getting 12 n cubed.
Okay, so the greatest common factor of 12, 48, and 36, the largest number that goes into all of them would be a 12.
Mm-hmm.
You okay?
Yeah.
And then n to the 5th, n to the 4th, n to the 3rd, n cubed goes into all of those. You take the lowest powers. Okay? Okay. Now, what are the leftovers? We have n squared minus 4n minus 3. Okay? Now, we've got a trinomial with a leading coefficient of a 1. So our next thing would be to see if we can factor the thing in parentheses. The n squared would be split apart, n and n. We're looking for a product that's -3 and a sum that's -4. Okay. Now, to get a product that's negative, you've got to have a positive and a negative, one of each. But to get a sum that's negative, that means that the higher power has to be negative. So -3 and 1 would be the only possibility. 3 and -1 wouldn't work anyway because the positive number is more powerful and we need a negative answer. But that doesn't give us a sum of -4. Now be careful. This doesn't factor any further, but you might make the mistake of saying, oh, it's prime. It's only prime if we couldn't factor anything. And we did factor something. We took out a greatest common factor. So the correct answer would be this thing right here. This part in parentheses doesn't factor any further, but we did take out a greatest common factor. So it's not prime. Okay. Any questions about that? All right. That takes us to number 31. We good to go on? Okay, so 6.2, number 31. And this is another review of things back from chapter 5. And I know it's kind of You know, the assumption is that you remember everything you did in the previous math class completely, and it's all right there in your brain. The truth of the matter is you probably haven't, you know, if you haven't done it for a while, you've kind of lost track of all that. And so it's good to clean out the cobwebs, and that's what we're going to do in this problem. It says, simplify the expression, write the answer without negative exponents. We have a to the 16th times a to the negative 8th over a to the positive 8th times a to the 0 power. All right, so let's focus on the numerator of this fraction. A to the 16th times a to the negative 8th. And the rules, they're back in chapter 5. If you want to, you know, if you want to go back and look them up, they're in chapter 5, I think section 5.2 covers all these properties of exponents. It says if you're multiplying two powers with the same base, you add the exponent. 16 plus negative 8 would be 8. So our numerator is now a to the 8th power. Okay. Now, in the denominator, same thing. Multiplying powers with the same base, add the exponents. 8 plus 0 is 8, so this is a to the 8th. Another way to look at that, recall something to the 0 power other than 0 to the 0 power is equal to 1. So this is actually a to the 8th times 1. So again, it's a to the 8th. All right, a to the 8th divided by a to the 8th. Well, we can look at this a couple of different ways. First of all, a number divided by itself, other than 0 divided by 0, a number divided by itself is equal to 1, isn't it? Also, there's a rule that says if you're dividing two powers with the same base, you subtract the bottom exponent from the top exponent. So this would be a to the 8 minus 8, which is a to the 0, which again is 1. So however you want to look at it, your final answer would be just 1. Okay. All right. Give me just a minute. I need to switch students in terms of questions. Okay, let's see here. This actually goes back to section 6.1 and number 31. Is that right? 31. I wonder if I got that wrong, because they got 31 correct, but they didn't get 3. Lindsay, this is you. Was 31 the one you wanted?
31 was the one I wanted. This is someone else's, but it's been like 6 years since I took 85.
Gotcha.
So
Gotcha.
I figured it out.
Okay. Because you got the right answer, but you just weren't sure what happened. Okay.
Yeah, I keep putting A instead of 1.
So this is what I've got for 6.1, number 31. It says factor the polynomial. Was it 6.1 or was it 6.2?
It was 6.2. Did I write 6.1?
Okay, now I understand. Maybe you did, maybe you didn't, doesn't matter.
No, it was the same question, just different numbers, but I kept putting A for my answer instead of 1.
Yeah, okay, so 6.2. Number 31. Yeah, that makes sense because 6.1, number 31, doesn't have any A's in it at all. So I was confused. Okay. Right. So it's kind of like the one we just did, but slightly different. So a to the 10th times a to the negative 5th over a to the 5th times a to the 0. So in the numerator, multiplying two powers with the same base, add the exponents. 10 plus negative 5 is 5. So a to the 5th power. Okay. All right with that? Okay. In the bottom, multiplying two powers with the same base, add the exponents. So again, we either get it this way, or you could say a number divided by itself equals 1. So the final answer is just 1. You all right with that? Okay, excellent. One more set of problems, or one more student. Let's see here. This is 4,400. This is again 6.2, number 31 again. Okay, so when you're bored this week, like that's going to happen, you might want to glance back at chapter 5. This one says a to the 12th times a to the negative 6 over a to the 6 times a to the 0. So again, multiplying two powers with the same base, we add the exponents. So we get a 1. Okay, does that make sense? All right, excellent. Yeah, and again, for section 5.2, there's a lot of different properties of exponents, and as they come up, we'll review them. But if you want to review them on your own, again, section 5.2. All right, so that's all the questions that people emailed me ahead of time. Are there any other questions that you didn't email me that you want to look at before we go on? If so, now is the time to speak. Nope, okay. We're going on to 6.3. Now, yesterday, we looked at factoring trinomials that had a leading coefficient of a 1. And if the leading coefficient wasn't a 1, that meant that we could take out some greatest common factor or take out a negative 1 to make it so that it had a leading coefficient of a 1. Today, the problems don't necessarily have a leading coefficient of a 1. So things are more complicated. And if you've looked at your schedule, you'll notice that we're actually going to spend 2 days on this section. There are 2 different fairly popular methods of using, and I'm going to cover both of them, okay? So today I'm going to cover the method that the book refers to as grouping, and then tomorrow I'll cover the method that they refer to as, I think it's trial and check. Let me double check here. Where does it go here? Some books call it trial and check. Other books call it guess and trial and check. Okay, because I've heard it called trial and check, guess and check, FOIL method. Okay, but anyway, that's tomorrow. Today we're going to use the grouping method, and I call it the ABCPS method, but it is the grouping method, and you will see shortly why I call it the ABCPS method. Okay, now let's start with this. 3x squared plus 4x plus 1. So here again, we have a trinomial. It's in standard form. There's no greatest common factor, and it doesn't have a leading coefficient of a 1. So we can't just go in and say the product is 1 and the sum is 4 and blah, 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 and jump right into the answer. We can't do that, okay? What I want to point out is that in terms of standard form, this would be ax squared plus, that looks like a 9, it's supposed to be an a, ax squared plus bx plus c. So for this problem, a is 3, b is 4, and c is 1, okay? So the coefficients of each term in standard form, a, b, c, 3, 4, and positive 1, okay? The next thing I'm going to do is form the product of a times c. In this case, 3 times 1, so the product is 3, okay? So in the previous section, the product was whatever that constant term was out at the right end. Now the product is a times c. And the sum is still equal to b. So the sum is still equal to that middle number. So the product has changed, but the sum is still that middle term's coefficient. All right. So the product is 3 and the sum is 4. Now we play the same game we did before. We look for a pair of numbers whose product is 3 and whose sum is 4. How about 3 and 1? 3 times 1 is 3. 3 plus 1 is 4. Okay. But now things are different as well. In the previous thing, we would have just had x plus 3, x plus 1, but we don't have a leading coefficient of a 1, so we can't do that. What we're going to do, though, we're going to take this original trinomial, and we're going to rewrite it, splitting the middle term into two terms whose coefficients are these two numbers. So we take the 4x and write it as 3x plus 1x. So we haven't changed the value of the original polynomial, but we've split that middle term up into two separate terms with the coefficients that we found in that step.
I have a question.
Yes.
So how we did 3 and 1, will that always, well, not those numbers specifically, but whatever like product we get, will that always go in the middle? That makes sense.
In the middle.
Yeah, like you know how we did 3 and 1, so in the middle we did 3x plus x to get 4x.
Oh, well, these two numbers that are the result of this process, yes. But the product is always a times c, the sum is always b, but then these two numbers we find, yes, we'll go there.
Yes, so the two numbers in any like scenario in this case, that would go in the middle?
Yep.
Oh, okay.
But these two numbers have to meet these two conditions. You following?
Yeah.
Okay, all right. And don't panic, because you're going to see, I mean, for the next, I think 33 minutes, I'm going to just be doing this over and over and over. Okay.
Oh, okay.
All right. It's not like, oh, here's one example. Now on to 400 other ideas. Nope. This is the big thing today. Okay.
Okay.
Now, how many terms do I have? 4. What have we done recently to factor something with 4 terms? We used factoring by grouping. So what we've done, we've taken this trinomial and split it up into 4 terms, and now we're going to use grouping. Okay? The greatest common factor of the first 2 terms is 3x. The leftovers are x plus 1. And if you're confused right now, go back and take a look at 6.1 again, because that's what we did in 6.1. The great, and I'm not going to look up, I'm going to look over, and I'm going to copy this, clone it over there. What do I need right here to make this a true statement? Well, I need a plus sign, but as I talked about, I think yesterday or the day before, I'm going to put a 1 there. It isn't necessary right there, but I want to put it there to remind me that I do need that 1 right there in the next step. And there is my answer. So I identified A, B, and C. I formed the product of A times C and the sum equal to B. I looked for a pair of numbers that met those two conditions, product and sum, took the middle term, split it up into 2 terms whose coefficients were those 2 numbers, used factoring by grouping, bada boom, bada bing. And there you have it. Any questions on this problem? All right, let's take a look at another one. Let's see here. 2b squared plus 7b plus 3. Now, careful, this polynomial contains the variable b. That's not the same b as this one, okay? Those refer to the coefficients. So this is 2, 7, and 3. The product is 2 times 3, which is 6. The sum is B, which is 7. And you can see why I call it the ABCPS method, hopefully. See.
Is the P a 6 or a B? I'm sorry.
Is the P a 6 or what?
Is it a 6 or a B? You put P equals.
Okay, let me ask you this. How do you get P? What do you do to get P? What do you take? What times what?
I'm just asking, like, what if
No,
you wrote 6 or P?
I understand. What I'm saying is figure it out. And what I'm getting at, I mean, I understand it looks like a B, but P is equal to A times C, right? What's A times C?
Oh, okay.
See? I mean, yeah, it's a 6. But yes,
Okay.
my handwriting is, well, believe it or not, I got an A in penmanship in first grade. However, when we got to, yeah, you're just going, yeah, right. But in 6th grade, when we did cursive, there's a reason they call it cursive. Well, I didn't get an A. We'll just leave it at that. All right. So we're looking for two numbers whose product is 6 and whose sum is 7. How about 6 and 1? Okay. So I'm going to rewrite the original trinomial, splitting the middle term, and those are B's there, into two terms whose coefficients are the 6 and the 1. And there's an implied 1 in front of the B there as well, but we don't need it there. Okay, so far so good. And now we're going to use factoring by grouping. The greatest common factor of the first two terms is 2b. B plus 3 is left over. Don't look up, look over. So it's got to be a B plus 3 there. And it would have to be a plus 1 outside. So this one's very similar to the previous problem. So taking out the greatest common factor, there's the takeout and the leftovers. I didn't do this on the last problem, but I'm going to do this now. I'm going to check my work. So this is going to be what? 2b squared plus b plus 6b plus 3, 2b squared plus 7b plus 3, check, check, check. So there we go. We good to go on this one? Any questions? So you got to find A, B, C, P, and S. Then you look for a pair of numbers who meet both P and S's conditions. Split the middle term, factor by grouping. Factor by grouping. Yes. Okay. Let's see here. This one's going to get ugly. 15a squared minus 28a. Well, maybe it won't. We'll see. Plus 5. Okay. So I've got a trinomial in standard form. There's no greatest common factor, and it doesn't have a leading coefficient of a 1. So a is 15, and this a is not the variable a. It's the coefficient of the leading term. B is negative 28, and C is 5. The product is 15 times 5, which is 75. The sum is negative 28. So far, so good? Okay, let's play the sign game that we did yesterday. The product is positive, so it's either got to be 2 positive factors or 2 negative factors. But the sum is negative, so it couldn't be 2 positive factors because those two numbers added together, a positive plus a positive, will not give you a negative sum. Answer, okay? So we're looking for 2 negatives. Let's see, how about negative 75 and negative 1? Well, that does give me the correct product, but the sum would be what? Negative 76. So we're a long ways from home on that one. Now, if you can just sit there and you can see that the answers are -25 and -3, then you don't have to go through all of this. But in case you do, I'm dealing with the deer in the headlight scenario. Like, I've got no idea what to do. Where can I start? That's the approach I'm taking, okay? Now, -75, it's not even, so I can't cut it in half. 3 goes in. What if I took -75 and divided it by 3 and took -1 and multiplied it by 3? That would give me a product that was +75. Oh, this was too easy. There, we found it just the second try, right? They're not always that quick and easy, as we'll see. But do you follow how I got from here to here? So there's my two numbers. So I'm going to rewrite the original trinomial, splitting the middle term into two terms whose coefficients are those two numbers. Okay? Oops. We ready to finish this problem? Factoring by grouping. Greatest common factor of the first two terms, 5a with a 3a minus 5 left over. So a 3a minus 5 left over. Oh, what's going to go on the outside? It's going to be a -1 in order to get this to end up like this, but this also had to match that, right? See why I took out a minus? So now the greatest common factor is 3a minus 5, and the leftovers is 5a minus 1. Everything in this process is mechanical except finding the two numbers. In other words, this process here is always the same. This process here is always the same. It's finding those two numbers that's the tricky part. Question, Mr. Mayo, I noticed that you wrote the two middle terms in the same order as the numbers were here. Does it matter which order we put them in? What if I wrote the -3a first and then the -25a? Would that change things? Well, yes and no. Let's take a look at that. Let's see, what is it? 25. Okay, so I've taken those two middle terms and I've just flipped them around. Factoring by grouping. Greatest common factor, 3a. Leftovers, 5a minus 1. 5a minus 1 minus 5. 5a minus 1. 3a minus 5. Oh, what did it do? It just commuted the two factors. So it doesn't matter which order you put those two middle terms. Okay. I went ahead and asked that and answered because eventually you would have asked it anyway. So just trying to save you the trouble. Okay. Again, remember, multiplication is commutative. So this factor times that factor is equal to that factor times that factor. And you're getting dizzy from all my switching back and forth. Okay. Let's see here. Let's do one that has, well, let's do that. Let's see how we doing for time. We got time. 13y squared plus 9y minus 4. So A is 13, B is 9, C is -4. The product is -52, and the sum is 9. Did I copy that right? I'm suspicious. 13y squared. Where did I get that? Minus 4a. Yep, that's right. That's right. Okay. So the product is negative. That means we've got a positive and a negative number, right? The sum is positive. So the more powerful one is positive. So I got a big positive and a smaller negative. Is everybody following how I came up with that? So since I want a big positive and a small negative, I'm going to start with the biggest positive and the littlest negative. Well, that would give me a sum of 51. So that's not right. What if I cut this one in half? Let's see, 26 and negative 2. Well, that would give me a sum of 24. What if I cut that one in half? Negative or 13 and negative 4. Bingo.
I'm kind of lost.
Okay.
I'm lost at how you're getting these numbers, like 52 times negative 1. You're getting 51 and 26 times negative 2. I don't know where you're getting those numbers from.
Where I'm getting these?
No, all of them. Like the
okay.
52,
Right.
26, 13, negative 1, negative 2.
Okay. Were you okay where I determined that we needed a big positive and a little negative?
Yes.
Okay, good. So I'm looking for two numbers whose product, is negative 52 and whose sum is 9. Okay. But I know the bigger number has to be positive. So what times what is negative 52? Well, 52 times negative 1 would be negative 52, right?
Yeah.
But what would its sum equal?
What? I don't get that part.
What's 52 plus negative 1?
Oh, 51.
So its sum is 51. What I'm doing is I'm picking a pair of numbers who match the product, and then I'm considering their sum to see if I get a 9. (52) times negative 1 is negative 52, right? But 52 plus negative 1 is not 9.
So you're trying to make it a positive?
I need to come up with a pair of numbers whose product is negative 52, but also whose sum is positive 9.
But we got 51.
So these aren't right.
Right.
What I'm doing is this. Okay, you ever play darts?
No.
You've never thrown a dart at a dartboard?
No.
Shoot. Well, I'm going to explain it anyway. Maybe it'll help. You know the idea of playing darts, throwing a dart at a dartboard?
Yeah.
Okay. So let's say you throw a dart at a dartboard, but you miss the bullseye. What do? You adjust your aim, right? Like maybe I throw a dart at the board and I missed the dartboard completely and I'm way over on the left side. So I know that, I need to adjust. I need to throw a little further to the right. And I throw again, and maybe I get a little closer. And I throw again, and eventually I get enough skill to where I'm, hopefully hitting the bullseye. But if I just stood there at the beginning and said, I'm just going to stare at the dartboard, I'm going to stare at it a while, and I'm just going to throw the dart and boom, get a bullseye. Probably not going to happen. So what I'm doing here is I'm trying to get closer and closer. How about this? Have you ever played the game where there's an object in a room and somebody's trying to find it? You say you're getting warmer, you're getting colder. You ever play that game? Okay. Yeah. So what I'm doing is trying to get warmer. But I've got to start somewhere. I knew that 52 and negative 1 were not the correct numbers. But I started there because I know I need a big positive and a little negative. And I said, okay, what does that give me? It gives me 51. Okay, that's not right. So let's try again. But I still want a pair of numbers whose product is negative 52. But an easy way I can get those, I can generate those, is if I take 52 and divide it by 2, I get 26. But since I divided the first number by 2, I have to multiply the second number by 2. 26 and negative 2. That's a pair of numbers that still give me negative 52. Do you see that?
Yeah.
But what's their sum? It's 24. I'm getting warmer. I still don't have 9, but I'm headed in the right direction because I went from 51 down to 24.
Okay.
So I need to generate another pair of numbers. Well, 26 is even. Let's cut it in half. So then we're going to double the -2. 13 times -4. These are just quick ways of generating two numbers whose product is -52. Okay.
Okay.
What's 13 plus -4?
9.
Aha, bingo. Now, this doesn't always work. I don't always hit on the exact pair of numbers doing this, but if I don't hit on them, I'll go past them. And then I'll have something too high and something too low, and we can work on what's in the middle. And when one of those comes up, we'll talk about that. So now I'm going to take my original and I'm going to split it up into two middle terms that coefficients are 13 and -4. So 9y becomes 13y and -4y. Okay? Leah, you all right with that?
Yeah.
Okay. Factoring by grouping. Greatest common factor, the first two terms, 13y, leftovers y plus 1, leftovers y plus 1. What goes out in front? -4. Greatest common factor, y plus 1, leftovers 13y -4, bada boom, bada bing. How are we doing?
Good. I understand it more now. So we're trying to find the two numbers that give us our sum.
Right. That you only choose two numbers whose product is -52, but of those choices, which ones give you a sum of 9? It's got to meet both conditions. But start with numbers whose product is that, and then see which pair also gives you that sum. Okay?
Okay.
All right, let's take a look at this one. This one has two variables in it. So let's see how we'll deal with that. 2m squared plus 17mn minus 9n squared. It's a trinomial. It's in standard form in terms of the letter m. If it ain't broke, don't fix it. So it isn't in standard form in terms of n, but it is in terms of m. So let's go with m. There's no greatest common factor. A is 2, B is 17, C is -9. The product is A times C, -18. The sum is B, or 17. Okay, product is negative. So we've got to have a positive factor and a negative factor. But the sum is positive. So the positive number has to be bigger than the negative number, right? How about a big positive and a little negative? Bingo, there they are. 18 times -1 is -18. 18 plus -1 is 17. You see that? Split the middle term. Be careful that you carry the m in down, not just the m or not just the n. Group it. Greatest common factor of the first two terms is 2m. Leftovers is m plus 9n. So the leftovers is going to be m plus 9n. And out in front, I'm going to get minus n, which gives me minus mn minus 9n squared. Here is a money-back guarantee. If you correctly find these two numbers, you will be able to factor it by grouping. If not satisfied, your money back, okay? All right. Greatest common factor, m plus 9n, leftovers, whoops. Leftovers 2m minus n. Let's check our work. 2m squared minus mn plus 18mn minus 9n squared, 2m squared plus 17mn minus 9n squared, check. Have I ruined the rest of your week? Just it only took me 10 minutes. Yeah. Okay, ready to go on? Here, negative 28 plus 6a squared minus 2a. It's not in standard form, so let's fix it. 6a squared minus 2a minus 28. So now it's in standard form. Oh, but there's a greatest common factor, a 2. So let's take out a 2. So we put it in standard form, took out the greatest common factor. Now we're ready to take the trinomial that's in the parentheses and apply all these things we've been looking at. Okay, so A is 3, B is -1, right? The coefficient of minus A is -1 and C is -14. The product is -52 and the sum is -1. The product isn't -52, is it? I knew something was wrong there. How about that? It helps if you can multiply. Now I'm feeling better about it. The previous one I'm going, this isn't going to work, but okay. Product is negative, so we got to have a positive and a negative. You add them together, you get a -1. So the two numbers have different signs, but they're only 1 apart, and the bigger one's negative. What times what is 42? Two numbers that are just 1 apart.
7 and 6 is 42.
Right, so which one's going to be negative? The 7. -7 times +6 is -42, and -7 plus 6 is -1. I'm going to change my parentheses into brackets because when I use factoring by grouping, it's going to produce parentheses. So I want to have my not have two different groups of parentheses going on. Okay, so I split the middle term and changed parentheses. Boy, I can't even talk, parentheses to brackets. Okay, factoring by grouping. 2. Greatest common factor of the first two terms is A, leftovers 3a minus 7, leftovers 3a minus 7, and I need a plus 2 right there to make it work. So I get 2 times 3a minus 7 times a plus 2.
Quick question.
Yeah.
Why did you need the +2 in the middle?
Here?
Yeah.
Because just the parentheses doesn't give me this. Okay, these had to match, but I've got to have 6a minus 14. So I've got to take 2 times that and 2 times that.
Got it. Okay, thanks.
Okay, yeah. So after I make these match, then I say, what do I need here to make this equal to that up there? We okay? All right, here we go. 8m squared plus 5m minus 10. This is a trinomial in standard form. There is no greatest common factor. It does not have a leading coefficient of a 1. Therefore, A, B, C, P, S, the grouping method. A is 8. B is 5. C is negative 10. The product is negative 80, and the sum is 5. Any questions so far? Okay, so now we're looking for the two numbers. The product is negative, so we've got to have a positive number times a negative number, or a negative number times a positive number, right? But their sum is positive. So of those two numbers, one positive and one negative, the positive number has to be dominant, has to be the bigger, the higher absolute value. So I'm looking for a bigger positive and a littler negative. Okay. So how about 80 and negative 1? That's the biggest positive and the littlest negative. That still gives me a product of negative 80. But their sum is 79. So that's not the correct pair of numbers. I was way off the dartboard. Missed it. I threw the dart and it landed in the other room. So now I want another pair of numbers whose product is negative 80, but whose sum is 5. Well, a quick way I can generate another pair of numbers, since 80 is even, cut it in half and double the second number. By cutting one in half and doubling the second one, I still get a pair of numbers whose product is negative 80. But now the sum is 38. Well, that's good news. I'm moving in the right direction. I'm getting warmer. Okay, but that's still not correct. I need another pair of numbers whose product is negative 80, but whose sum is 5. 40 is even, cut it in half, double the second number. 20 times negative 4 is negative 80. But the sum is 16. Not correct, but again, I'm getting warmer, right? See how I keep getting closer and closer? All right, everybody okay so far?
Yeah.
All right. Let me know if you're lagging behind. If you need to catch up with Mayo, let me know. Okay. All right. Now, this one isn't right. Cut it in half and double that, and I get 2. Oh, I've gone too far. You see that? I went past the 5 all the way to the 2. The number we're looking for is in there. So the pair of numbers I'm looking for has to be in there. Do you follow my logic? I can see Lindsay's getting the head there.
Would the numbers be 10 and 10 minus 5?
But that wouldn't be a
or
product
15.
of
Would it be 15 and 15 minus 10?
but
to get 5?
but 15 and negative 10 don't have a product of negative 80.
Oh.
Here's the deal, okay? One of the numbers has to be between 20 and 10. The other number has to be between negative 4 and negative 8. Does everybody see why that's true? There's less numbers between negative 4 and negative 8. So I'm going to try negative 5, negative 6, negative 7. Okay? Well, if it's negative 5, it would be what? 16 and negative 5, which gives me 11. So that's not right. If it's negative 6, negative 6 doesn't go into negative 80 evenly, does it? And neither does negative 7. So I got it too high, got it too low, investigated all the possibilities in the middle, and none of them worked. What's your conclusion? Prime. Good job. I can read lips. Okay. Oops. Too many humps on that camel.
It always gives you a headache before you realize it's prime.
Yeah, but here's the deal. The reason that I did it this way, let me tell you the wrong way to do it. The wrong way to do it is you just randomly pick pairs of numbers whose product is negative 80. How do you know you've tried all of them? How do you know that you've eliminated? By doing it this way, I keep moving closer and closer. You know, I got warmer and warmer, and then I went too far, but I knew it had to be somewhere in the middle. So then it got down to only 3 numbers to try. 2 of them didn't even go into it. So I had a strategy to eliminate all the numbers. So often students will call in a product or a polynomial prime when it isn't, because they just tried a couple things and they didn't work. So they thought, oh, it doesn't work. But you got to have a way of narrowing it down. All right. I see that our time is up. I've tortured you enough for one day. I will be back this afternoon at 1:15. So if you should have need of me, otherwise I will see you tomorrow. I'm going to go ahead and stop the recording.